Okay, hi everyone. Good morning, good afternoon, and good evening to everyone. And thank you for joining us today. I just share my screen, it's not working. Sorry about this, 1 second. Okay, there we go. Now you can see it. So welcome to our IIASA public webinar. I'll be your moderator today. My name's Ed Byers and I'm a senior research scholar in the Integrated Assessment and Climate Change Research Group of the IIASA Energy, Climate and Environment Program. This is our 9th event in the series that highlights important work IIASA has to offer in a public audience, and we have a great lineup of speakers today. IIASA conducts policy-oriented research, typically using systems analysis to approach problems that are too large or complex to be solved by a single country or academic discipline. Our researchers use applied systems thinking to tackle challenges facing our society, such as climate change or just societies, natural resources management, just to name a few. They typically partner with other scientists, governments, and local entities to create broad understanding of problems that concern us all. Deliver important scientific information that is then used at different levels of government to make decisions on the future of our society. We believe this information should be available to all, and also interested in new perspectives, which is why we've launched this series. It's a conversation with IIASA experts, begins with some presentations and then opened up to a Q&A. We've had almost 250 registrations for today's event, so please get your questions in quickly. And if there are other questions that we don't get a chance to answer today, can follow up with you afterwards. We'll send around a short survey at the end of the event and be hugely grateful if you have a few minutes to fill this in. So onwards to today's event about the IPCC. We've reached the end of the 6th assessment cycle, and we have new chairs elected for the 7th assessment cycle 2 weeks ago in Nairobi, which you may have seen in the news. In the 6th assessment cycle, there was a main report from each of the 3 working groups, which will be explained in the presentations, and additionally 3 interdisciplinary special reports, including the very high-profile 1.5 degrees report, which came out in 2018 and included contributions from all 3 of the working groups. And on this call, we've been very much involved. In total, actually, AR6 cycle reports featured 32 authors from IIASA, and a number of them from across multiple reports and chapters. Today, we have special 3 of leading researchers from IIASA who are involved in IPCC, and today we'll reflect on the findings, including the synthesis report that was released in March this year. So firstly, it's my pleasure then to introduce our first speaker, Leila Niamir. Leila is a research scholar jointly associated with the Sustainable Service Systems and Transformative Institutional and Social Solutions Research Groups of the IIASA Energy, Climate, Environment Program. She's a computational economist working on energy and climate change mitigation. Her research focuses on science policy interface, agent-based modeling, behavioral and lifestyle changes, and sustainable development goals and well-being. Leila serves as an author in Working Group 3 for the 2002 IPCC Climate Change Report on mitigation of climate change, and also the latest 2023 IPCC Synthesis Report. So over to you, Leila.
Thank you so much, Ed, for a very kind introduction, and greetings, everyone. At beginning, actually, I should apologize. I was in a dentist this morning and still I'm a little bit in pain and numbness. So actually, I'm trying to be a little bit slow to avoid any injury in my mouth, but actually it's good because usually I'm really fast in talking. So this helps to be more, going more smooth. While I assume that many of you are already familiar with the IPCC, I would like to offer a very brief introduction or basically overview of the IPCC. And next slide, please. IPCC is a critical global initiative that is shaping the way we understand and address one of the most pressing challenges in our time, which is climate change. IPCC plays a very important role in gathering, synthesizing, and disseminating cutting-edge scientific knowledge around the climate change. Constituted by hundreds of the devoted and committed researchers and professionals from across the globe, IPCC translates these complex scientific findings into the accessible knowledge, accessible language, empowering governments, communities, and individuals to make well-informed choices and thereby ensuring the preservation of a planet's future. Next slide, please. The IPCC established in 1988 by United Nations. And as you can see, there is lots of reports and lots of assessments happened since then. Usually is in basically categorizing as a cycles that happening. And as Ed mentioned, we just finished the sixth cycle of assessment and kick off the seventh cycle of the IPCC assessment. Its mandate of the IPCC is clear and urgent to provide an objective and comprehensive assessment of the science behind climate change, the potential impacts that they have, and of course, strategies of the mitigation and adaptation. There is more information about IPCC that you can look through their website, is ipcc.ch. And then basically now I really would like to more focus on a last cycle, or basically the sixth assessment report. And as you can see, since 2018, there are a variety of the reports published in this cycle. Next slide, please. There are many assessments, as you can see, from the different cycles happened, and you can see the brief, all of them in their website. Next slide. In the sixth cycle of the assessment, we had three main working groups, which basically come up with the three main reports, three special reports, and one synthesis report. So in total, we had 7 reports. Working group 1, which is focusing on a physical science and earth science. Working group 2, mostly focusing on adaptation and vulnerability. And working group 3, which is a mitigation of the climate change. Since that all of you know that this takes time, that each of these working group publish their final report, in between, there are lots of special reports that focusing on a particular topic, which is very important because in many of them is a gathering of the whole 3 working group, all the scientists working together. And as Ed mentioned, one of the important one is 1.5 degree, which is the first time that 3 working groups basically worked on this topic. This special report, it was a land report, 1.5 degree report, and ocean report. And basically the rule of the synthesis report is synthesizing these 6 basically reports in one piece and showing the kind of what's the last finding and what's the basically cross-sectoral or cross reports finding through that. Now we are going to deep in a synthesis report. Next slide, please. The synthesis report actually has I can say it if I want to do it in a simple words, there is 3 main direction. First is giving the warning to you. What's the status of the Earth right now? What's the piece of the, we lost, I think, our Excel file. Yes, thanks. What's the scale and piece of the climate actions, which actually shows that is not sufficient enough to tackle climate change, and also shows the different impacts that these human-caused changes could intensify the water scarcity, food production, human well-being and health, and also cities, settlements, infrastructure, ecosystem structure, and species range shifts and changes in timing. But while warning us about this issue, also giving some hopes, showing that there is a lot of options that if we act right now, I'm really emphasizing right now, we would be able to reduce losses and damages for nature and people. And actually also we show that there is a climate actions is also provide lots of co-benefits. So basically, we try to show that there is a multiple feasible and effective option are available right now to cut the GHG emission and adopt human-caused climate change. But still, we have lots of challenge. As we know that we are very behind, and we do need to cut emission immediately. And basically, Joeri going to present on that basically, we do need to nearly halve the emission by 2030, and that's why this is very important to see how we can scale up these practices and infrastructure to enhance this resilience, and what type of actions we do need. And basically, the message is that in all level of the governance and all people need to act right now. Since that I'm coming from new generation as a young scientist, and also I completely understand the new generation that little bit the climate fatigue and always little bit pessimistic about the actions, I want to start with hope, bring a lot of hope to the people. And then after me, Joeri, my colleague, will talk about the warnings and basically what's the scale and the piece of the climate actions, what we are standing right now, what's the status. And my colleague Shonali also talking about the challenges and how we can scale up, and then how basically these actions could be basically implemented. Next slide, please. As I said, in a hope, one of the iconic figures, it was the figure 6 of the synthesis report that shows that there is multiple and feasible and effective option both in climate change mitigation and adaptation that could reduce greenhouse gas emission and adopt a human-caused basically climate change. There is two panels, panel A and panel B. In a panel A, the focus is on basically both climate change mitigation and adaptation. At the left-hand side, you will see the adaptation strategies, and the right side is the mitigation strategies. And also in the middle, it shows that how basically they are synergy between these climate actions. They categorize in a different systems. I'm not going to the detail right now, but the main message here is that, would you please go to the next slide? The main message in the panel A is that there are lots of strategies with a low cost if we really act now, for example, like investing on a solar or also wind. But however, there is also, of course, we know that there's a lot of technologies that could reduce basically that like carbon capture, storage, or other type of techniques to remove, but these are for now is a really high cost. So the message is that we should really act now and use the opportunity to basically cut the emissions as soon as possible. So basically, the majority of them is there are options that is less than $100 US per ton, or less than that could basically reduce or cut emissions by half by 2030. In panel B, actually, we discussed for the first time in a history of the IPCC. Next slide, please. Basically, then this is actually comprehensive coming from working group 3. The panel B was actually the summary of that. The reason that I wanted to emphasize in that figure, which is in the working group 3, and then summary in the working group in a synthesis report, is that for the first time in a history of the IPCC, there was a dedicated chapter on the demand side, services, and social aspects of the climate change. And in this chapter, we tried to show that how much demand side and services could influence on the reduction of the greenhouse gas emission. So far, most of our attention or most of our focus was on the supply side, technology perspective, but we are missing the looking at how much us as a people could also influence on a reduction of the greenhouse gas emission. As you can see in this figure, we show that the light gray bars shows that full potential. I mean, basically the business as usual. If you just continue like this till 2050, we emit the greenhouse gas emission. And then basically the blue, red, and yellow charts, it shows that how much we had a reduction in a greenhouse gas emission if you are taking the demand side actions. One click, please, on this slide. Basically, we categorize on them on the social cultural factors, like, for example, let's focus on land transport, switching to walking, cycling, and basically avoiding the private car. This is one action of the social cultural factor. Or infrastructure use, basically using the public transport or shifting to the public transport, or this could also has a reduction. These are also shows based on this color category that I'm now showing. And the last but not least is the end use technology options. We have a lots of improvement in the technology, and if you adopt this type of technology, like for example EVs, I mean electric vehicle, how much we can influence on the reduction of the greenhouse gas emission. As you can see for this waterfall figure, it shows that from that light gray bar, we can have this much reduction by 2050 just through the demand side actions. And then the rest actually, which is stay as a basically dark gray bars, that is something that the supply side or the technology or renewable technology could take over of that if we want to reach to our targets. There are lots of examples that I can talk about it, but the main message is that the demand side actions, basically particularly focusing on the food, land transport, and building, we could be able to cut 40 to 70% of the greenhouse gas emission by 2050 through these options. These options vary from the food, like dietary shift through the balanced and sustainable healthy diet, to, for example, social practices, to changing our lifestyle and then reducing the emission and basically energy consumption, through the design, like a compact city and public transport, and then also the basically technology improvement, like an electric vehicle, and then all new appliances, or basically the high level appliances, energy saving appliances that we have. For now, I will stop here. I will pass it to my colleagues that they are talking about, as I mentioned, these are hopes that I'm saying that there's a huge hope that we have, but we should really, really act now. I will pass it to Joeri, that's talking about more on a warning perspective, and also Shonali on a challenging. Back to you, Ed. Thanks.
Thank you very much, Leila. So next, we're very happy to welcome Joeri Rogelj to give his presentation. Extremely esteemed researcher, doesn't need an introduction, but is senior research scholar here at IIASA in Energy, Climate and Environment Program. Explores how societies transform towards more sustainable futures, and his research crosses many disciplinary boundaries, from earth sciences to study of societal change and policy. He's published on carbon budgets, net zero emission targets, pathways to keep warming to 1.5 degrees in context of the UN Paris Agreement, a major contribution there, and interactions between climate, sustainable development, and justice. In the past decade, Joeri has contributed to many and major scientific climate change assessments, including for over a decade on the annual emissions gap reports from the United Nations Environment Program. He's contributed to all 3 of the main reports from the IPCC Fifth Assessment Report, served as coordinating lead author on mitigation pathways for the special report on global warming of 1.5 degrees in 2018, and was lead author for the latest 6th assessment report also. And he also holds a position as professor in climate science and policy at the Center for Environmental Policy in Imperial College London, and also more recently a member of the European Scientific Advisory Board on climate change, reporting to the European Commission. So over to you, Joeri, and thank you and welcome.
Yeah, thank you very much, Ed. And in the 10 minutes that I have to speak about the IPCC 6th assessment cycle, I want to take you on a journey that looks at how the IPCC 6th assessment cycle went from diagnosing the illness of climate change to identifying a cure. So on this slide, which is one of the figures of the physical science assessment of the IPCC, you see 3 panels. And these 3 panels provide important different types of information. Let's go through them in turn. On the left hand, you can see a gray bar. That gray bar is the total warming that we have observed, which is basically the combination of all the measurement stations, all the measurements that we have of the global temperature. And we see that today, or in the last decade, this is for 2010 to 2019, we are about 1.1 degree higher than in the late 19th century. Now, knowing that it has warmed doesn't mean that we know who is responsible for this. And that is why these other 2 panels provide us with that information. Let's first look in the middle panel. In the middle panel, and starting with the largest red bar there, we see that if we take all the evidence together, we see that global greenhouse gases emitted by human activities have caused around 1.5 degrees of warming already. That is more than the warming that we have experienced to date. And why have we only seen 1.1 degrees of warming? That is because at the same time, we are also emitting small particles. We produce air pollution that is cooling the planet at the same time. You can see in the middle panel that basically all of the warming that we are experiencing to date is caused by human activities. The right-hand panel then provides an even more detailed pictures. Without going into detail of each bar here, I want you to focus on the left 2 bars, which show the contribution of the 2 most important greenhouse gases, carbon dioxide and methane. And now, having understood what is causing this warming that we are experiencing, let's go to the next slide to see what the solution is that, or what needs to be done to halt global warming. Here, the IPCC, this is another figure from the physical science assessment, has identified that there is a near linear relationship between the cumulative emissions of CO2 that are ever emitted and the total global warming. And that is illustrated here on this figure. You can see cumulative emissions of CO2 on the horizontal axis, global warming on the vertical axis. And the wiggly black line are the observations. So that is what we have already experienced as a world. And the colored shapes are future projections. And you can see that both in the past and going into the future, we see a very clear near linear relationship between those 2. We also see there a real clear consequence of this, and that is that at some point we need to stop adding CO2 to the atmosphere. And that is illustrated by the bars at the bottom, where you can see the pace of CO2 being added to the atmosphere being very different depending on which path we take for the future. If we go to the next slide, then we can ask ourselves, how do we stop adding CO2 to the atmosphere? And the key word here is zero emissions, or even more precise, net zero CO2 or greenhouse gas emissions. Well, what are these 2 concepts? The IPCC highlights that net zero CO2 emissions is the state where all remaining CO2 emissions are balanced by anthropogenic CO2 removals. And you can see it here on the left-hand side, illustrated by the black square. Reaching net zero CO2 emissions is a requirement for stabilizing the warming that is caused by CO2. If we reach net zero CO2 emissions, we expect there to be no further continued warming from CO2. Now, reaching net zero greenhouse gas emissions is differently. That is when all greenhouse gas emissions and removals are balanced. And in order for us to be able to compare them, we need to put them on a similar scale, which we do with greenhouse gas metrics. If we do this in the way that is mostly done in climate policy circles, reaching net zero greenhouse gas emissions will actually achieve more than just the stabilization the IPCC highlights it that if we reach net zero greenhouse gas emissions, this is projected to result in the decline in surface temperature after an earlier peak. So we would reach a peak and decline pathway from a high level towards a safer, lower level. On the next slide, we can then look how this translates in actual transformations of our global economy. And this is a figure from the synthesis report that shows the global emission pathways. First of all, the red range shows where current implemented policies are bringing us, which is obviously not yet a path where emissions are reducing very steeply on a global level, and which would lead to global warming of around 3.2 degrees, with a range of 2.2 to 3.5 degrees. More important, however, if we're thinking about the cure that we want to find for climate change, we are looking at the ranges at the bottom, and particularly the range that limits warming to 1.5. There you can see that both pathways that limit warming to 1.5 and that limit warming to 2 degrees overlap with reaching net zero greenhouse gas emissions. On the next slide, then, we can split this up and look in more detail at the individual greenhouse gases. Here I highlight the two most important greenhouse gases that I introduced before, carbon dioxide and methane. And you can see that for carbon dioxide, all pathways limiting warming to 1.5 and 2 degrees basically reach net zero CO2 emissions and even go negative thereafter. That means that we are removing more CO2 from the atmosphere than we are emitting into it. For methane, the picture is slightly different. At the bottom here, you can see that while we see strong reductions in methane compared to where they are today, methane is not reduced to zero levels. And that is because there are still important sectors, including the agricultural sector, where we have not identified options or measures to fully eliminate all emissions of methane. Looking on the next slide then, the previous still, we can look at the timing and thus consider the benchmarks that we would need to hit to be in line with a 1.5 or 2 degree pathway. And that is illustrated here at the bottom. You can see that net zero CO2 emissions in a 1.5 degree pathway are reached in the 2050s, while net zero greenhouse gas emissions are always reached after having first reached net zero CO2 emissions are reached from the 2070s onwards. And if we then now go to the next slide, we go even one step further, one step with more detail. We look at what are the key characteristics to achieve these deep emissions reductions. And particularly this slide just focuses on a net zero CO2 energy system. And there are key characteristics there that any such system would have. The IPCC highlights that such a system sees substantial reductions in overall fossil fuel use, with minimal use of fossil fuels that are not abated, so that are not connected to carbon capture and storage. There is a large upscaling of carbon capture and storage in any remaining fossil fuel use. We pretty much try to electrify everything, with electricity being produced at zero CO2 emissions. And where electrification is not possible, we have to go towards alternative low carbon energy carriers. Finally, as was already highlighted in the previous presentation, energy conservation and efficiency is absolutely essential. On the right-hand side, the figure shows how the energy system, which are the blue features in this figure, contributes around half of the emissions today or in 2019. But if you look on the right-hand side, these are 5 different ways in which we can reach net zero CO2 emissions. And you can see that in all of these worlds, the energy system produces either 0 or even net negative CO2 emissions. And if we then go to the last slide, I hope that this presentation could really show you how in the AR6 the IPCC was able to more robustly and more strongly than ever show what or diagnose what the causes are of climate change, who is responsible, but then also the measures and the cures that are required by society to deal with it and to stop climate change in its path. And with that, I'd like to hand over back to Ed.
Great. Thank you very much, Joeri. So quickly before introducing our next speaker, reminder to the audience, please get in any questions that you have for the speakers into the Q&A chat box now during the talk, because we're collecting the best ones and we will probably need to group a few of those questions together for the Q&A session that will follow Shonali's talk right now. So my pleasure to introduce our final speaker, Shonali Pachauri. Shonali is research group leader of the Transformative Institutional and Social Solutions Research Group in the Energy, Climate, Environment Program. She served as lead author for IPCC Working Group 3, AR6 report, as well as also the Synthesis Report. Shonali's research focuses on the role of social, institutional, and technological innovations for inclusive human development, particularly for those people without access to basic infrastructures and services. She coordinates and leads research on analyzing heterogeneities in energy and infrastructural access and use. Her work explores pathways for achieving universal access to decent living energy services for human well-being, and assessing wider impacts of this for sustainable development. She's published extensively on these topics, both in form of scientific peer-reviewed articles and policy reports. Over to you, Shonali, please.
Thank you so much, Ed. It's great to be part of this webinar, and welcome again to all the attendees that have been kind enough to join us on this. So in the next few minutes that I have to present here, I'm really going to focus on discussing some of the ways in which the assessment highlights aspects related to equity and really embeds climate action within the broader sustainable development agenda. And one of the things to mention is that since the last assessment cycle, that is AR5, there's been much more research that has been done to connect sort of physical impacts of climate change to socioeconomic and justice implications. So that's one of the things I'm going to be talking about a little bit. And then also there's been a great expansion of the attribution literature, which tells us that, the extreme weather phenomena that we are experiencing today, whether these can be really attributed to human-induced climate change. So I'll talk about both of these things a little bit. So in this first figure that we are seeing, what's important to highlight, and I think Leila already mentioned this in her presentation, is that for the first time ever, the term loss and damage is mentioned in the IPCC Synthesis Report. And this is really illustrated in the figure on the right in what you're seeing. And what's been acknowledged is that there's an improved understanding of what constitutes both economic and non-economic losses and damages. And so, one of the key findings from the assessment is that climate change has already caused widespread adverse impacts and related losses and damages, both to nature and people, and that these are unequally distributed across systems, regions, and sectors. So economic damages from climate change that have been detected include those to exposed sectors such as agriculture, forestry, fisheries, energy, and tourism. And individual livelihoods have been affected through, for example, destruction of homes and infrastructure, loss of property and income, and human health and food security. And basically, there have been adverse effects on gender and social equity as well. So the figure on the left then illustrates how the climate has already changed and will change along the lifespan of 3 representative generations, those born in 1950, 1980, and 2020. And it's showing alternative emission futures, and that we have already committed to 1.1 degrees Celsius of warming to date. And then, of course, what are the potential increases to 2100 in the style of the famous climate stripes? So what is clear from this figure is that even if we cut all emissions today and limit global heating to less than 1.5 degrees Celsius above pre-industrial levels, in line with the Paris Agreement, we are leaving a much hotter world to our children than what we've inherited. This is because even if we stop emitting all greenhouse gases today, global warming will continue to increase in the near term, that is between 2020 and 2040, mainly due to the increased cumulative CO2 emissions that Joeri also alluded to in his talk. So this really points to the big intergenerational debt that we have already run up. Next slide, please. Another key finding is that the risks and projected adverse impacts and related losses and damage from climate change will escalate with every increment of global warming. So as climate change worsens, risks will become increasingly complex and more difficult to manage. And what the graphic is illustrating is some of the regional impacts of climate change at 1.5, 2, 3, and 4 degrees of global warming. And basically what we are seeing is that continued global warming is projected to further intensify the global water cycle, including its variability, which means that we will have impacts on the monsoon and precipitation, so very wet and very dry weather extremes and climate events. And the proportion of the global land area that will experience these variations in seasonal mean precipitation is also projected to increase, with more variable precipitation and surface water flows over most land regions within seasons and from year to year. What we are also seeing in the bottom half of that graph is impacts of these weather impacts, weather extremes on human well-being, for example, through crop production. So we are seeing that climate-driven food insecurity and supply instability is projected to increase with increasing global warming. This, of course, could also interact with non-climate risk drivers, such as competition for land between urban expansion and food production, pandemics, conflicts, and so the impacts and vulnerabilities differ substantially across different regions, which is what is an important take-home message from this work. Next slide, please. What we're also seeing is that since the last assessment cycle, the research has shown that mostly it's marginalized both economically and socially populations that are hit first and hardest by climate impacts, both in the global south and the global north. So basically what we are seeing is that the impacts of climate change can further exacerbate marginalization and injustices. So already today, between 3.3 and 3.6 billion people are living in contexts that are highly vulnerable to climate change, where vulnerability is highest in locations with poverty and governance challenges and limited access to basic services and resources, violent conflict, and high levels of climate-sensitive livelihoods. It's also clear that the world's poorest and most vulnerable are at risk, including from mortality and other health consequences of extreme weather. Over the last decades, the mortality that we've seen from floods and droughts and storms has been 15 times higher in the most affected countries, including most of Africa and large parts of Central America, compared to less affected countries like those located in Western and Northern Europe. One of the findings of the report is that between 1970 and 2019, almost 90% of the deaths from weather, climate, and water hazards across the world have been in developing nations. Next slide, please. What's important also is that when we look at the historical contributions of CO2 emissions, these vary substantially across regions and continue to differ widely. So what the two graphs on the right show you are differences in cumulative greenhouse gas emissions and what the emissions are today across regions. And in 2019, what one sees is that 35% of the global population is living in countries emitting more than 9 tons of CO2 equivalent per capita, while about 40% live in countries emitting less than 3 tons of CO2 equivalent per capita. So what we are seeing is that there are huge regional differences, and these regional differences are very evident both when we are looking at the cumulative emissions over time, as well as if you look at the per capita emissions today. And particularly in small island developing states and the least developed countries, which are not depicted on the graphs, these regions have much lower per capita emissions, have also contributed much less cumulatively to emissions over time. The last figure on this page shows you the average level of vulnerability amongst a country's population against the emissions per capita in 2090. And this is at the country level for about 180 countries. And what we are seeing is that countries with relatively low average vulnerability often have rather, those countries with a relatively high average vulnerability are the ones that have often contributed the least to the problem in terms of emissions. Next slide, please. So one of the other key findings from the assessment was that climate resilient development, which is basically development that integrates adaptation and mitigation to advance sustainable development for all, is a good strategy in terms of addressing climate change. And in the past, these climate resilient development pathways have been constrained by emissions and climate change, and they are progressively constrained by every increment of warming, in particular beyond 1.5 degrees Celsius. But climate resilient development can be enabled when governments, civil society, and private sector make inclusive development choices and prioritize risk reduction, equity, and justice. The figure shows that there is a rapidly narrowing window of opportunity to secure a livable and sustainable future for all. And there are diverging pathways that interact among choices and actions made by governments, private sector, and civil society. These can either advance climate resilient development or can basically, obviously, worsen things. And so basically, the choices that we are making today and the options in front of us that we've highlighted today, they can be enabling us to really take effective adaptation and emission reductions options. And the further we delay them, the fewer effective options remain to us. Next slide, please. So the synthesis report also lays out how climate adaptation and mitigation actions can translate into co-benefits that aid countries' efforts to meet the SDGs. So there are many mitigation and adaptation systems that can help countries to meet their near-term development goals in energy, urban, and land systems. And so you're seeing all the SDGs there listed in the rows, and on the columns on the top, you have the systems that where these synergies and trade-offs have been assessed. And according to the report, both sets of actions have more potential synergies than potential trade-offs with the SDGs. This, of course, depends on the scale and context of how mitigation and adaptation measures are implemented, the interactions between and within different sectors involved, and the cooperation between countries, as well as things like governance, policy design, and how the options are timed and sequenced, and the stringency with which they are deployed. But basically, what this graphic represents is basically you're seeing a lot more blue than you're seeing orange. And that really highlights the fact there are many, many mitigation and adaptation actions, which when taken together can really benefit achieving the sustainable development goals as well. In some cases where there are trade-offs, basically, these can also be overcome by things like social safety nets, land restoration, and so on, that then accounts for the potential mitigation trade-offs, potential trade-offs between the goals. Next slide, please. So I'm not going to try and in any way summarize what has been presented here. Of course, the findings we presented are a limited set of findings, but I'll leave you with some of these last messages that really emphasize how the choices that we take in this decade will really determine the future. And with that, I'd like to thank all of you and look forward to the questions and answer session after this. Thank you very much.
Great, thank you very much, Shonali, and to all of our speakers. And so now we move on to the exciting Q&A session. I've been juggling lots of questions flying in during this time and trying to aggregate them, and kind of some of them are very similar and bring them together. So hoping also for some short answers so we can squeeze in lots of questions. And I'll go back into the order of the way that the speakers have been speaking. So kind of combining a few questions, going to go back to Leila. We had one or two mentions, both in terms of is energy demand reduction compatible with economic growth, and also more about what are the raw materials required for this big transition if we imagine lots more renewables, wind turbines, electric vehicles, electrification, and what about the importance of the circular economy in this. There was an answer in the chat that Leila gave, but could you just expand a little bit on this for us, please?
Sure. Thanks, Ed, and thanks for the questions. Actually, we did this assessment. We showed that how demand side mitigation options, the one that I showed, that from the different perspective could actually directly consist with human well-being and basically economic growth. And this is actually a very big assessment through all the majority of the authors from the different sectors. We looked through it to come up that showing the co-benefit of all these demand side mitigation options through different human well-being dimensions, which one of them is economy and economic growth, basically. And we show that this is consistent with human well-being, particularly looking through the first kind of series of the SDGs on like energy and water and food, and particularly we expanded that through the social kind of dimension, looking to the social cohesion, security, and etc. And the short answer is that yeah, these assessments happened, and there is a consistent and with high confidence that they are related. Regarding to the circular economy and raw materials, particularly, this actually is one of the options that we also consider from the industry perspective, that reusing basically and recycling and in general the circular economy concept has a high impact on mitigating climate change, and has a huge potential about around, if my mind could help me, is around 60% by 2050. And last but not least, about electrification, if you could remember that we had, I showed that this sectoral actually waterfall figure, and there was another additional figure that looking for the electricity. And actually we show that we know that some of these options toward the electrification, but also, for example, like EVs and other perspective, but through the also social behavior perspective and demand side option, we can also reduce this electrification upstream, basically, emissions. I think I will stop here. Happy to continue because I know that there's many questions coming up, but I will continue in a chat if needed. Thanks, Ed.
Thank you, Leila. Okay, so next on to Shonali, also combining a few questions and building on the research you do at IIASA. So how to evaluate and assess the alternative and often competing policy interventions and recommendations that maybe come up within IPCC, how following these recommendations to ensure efficient and effective implementation at different governance levels, but ultimately for people, I think, how to ensure a just transition, and how in the IPCC reports, in your experience, have social and ethical perspectives been taken into account?
Yeah, thank you very much. Very interesting questions, and of course, big questions that require big answers. But in brief, actually, some of those last slides that I presented in particular are one way in which the assessment has tried to really evaluate how different types of interventions can have either, in some cases, synergies, and in other cases, trade-offs with broader sustainable development agenda. And in particular, what I was trying to emphasize also is that the assessment finds that there are in most cases more synergies than trade-offs in terms of the different options available. And in cases where there are trade-offs, there are also opportunities to either avoid or ameliorate these trade-offs through the design of the policy and through basically, so I could give you an example, for instance. Of course, when you have a climate mitigation policy, which might, for instance, increase the cost of energy for certain parts of the population, there are many options through the design of policy, like through cross subsidies or shielding the poor population groups, to really ensure that both climate mitigation and affordability of energy is maintained. So that's sort of one of the key things that has been highlighted in the report. In terms of implementation, the report again highlights that there are sort of some key things that are important for effective implementation. That includes things like effective institutions, adequate governance, and of course finance, which is a big part of the report as well, really highlighting the scale of investments that are required to carry out the adaptation and mitigation actions, and where it is cost effective to do these interventions, and also what is required in terms of really transfers of finance across regions, both from public and private sectors. So yes, I mean, of course, there's much more that can be said as well in terms of what can be done and how we can ensure that effective implementation takes place. But I'll leave you with that for now, and maybe we should go to some other questions as well. Thank you.
Thanks, Shonali. Okay, and on to Joeri. Question a little bit about the assumptions, scenarios, models that have been used in IPCC reports. At the one end, we've seen actually very high warming scenarios that have possibly, or due to good mitigation, have been scarier than have actually played out, like so-called RCP 8.5. And at the other end, some people are asking how realistic are the assumptions in some of these mitigation scenarios, for example, relating to technologies like carbon capture and storage. Do we have geological storage to keep that carbon in the ground? And what about other carbon dioxide removal, like afforestation? Do we have enough land available to sequester the carbon that is included in some of these scenarios?
Yeah, really good question. So let me start on the higher end of the emission scenario questions, and with the observation that the IPCC has kind of reduced its focus on the highest emission scenarios that are available in the literature, and that lead to warming of like a central estimate of warming of close to 4 degrees by the end of the century. The reason for this is that today we are living already in a different world, where renewable and the advances in renewable energy, and particularly the cost reductions in renewable energies, have been so significant that in many cases the energy system portfolio, or the choices that are made in these very high emission scenarios, would not be economically would not make economical sense anymore. And so it is quite unlikely that they will really materialize. I think the IPCC takes a correct approach by not excluding them from the assessment, by still presenting them, but at the same time also presenting the context in which they have to be understood, and which is, for example, projections of where current policies are leading emissions and therefore also global warming. These high emission scenarios, they're not impossible, but they in many cases would involve a reversal of current policies, which of course is not excluded, but is a particular track to be followed. Then on the lower end, yes, and this, how feasible are these deep mitigation scenarios? And there is a general critique of the kind of models and the kind of scenarios that the IPCC needs to assess. And that critique always cuts both ways. On the one hand, they're way too ambitious, and on the other hand, they're way too conservative. And that is because these scenarios, they don't tell us what the real world does, but they give us indications of and thought experiments of what might be possible. So we need to interpret what these scenarios tell us in the context of what we know, what the political decisions need to be that are required to make these scenarios happen, and also what other objectives are or other things are that we as a society care about. Not every scenario that is available is either possible or desirable. For example, there are scenarios that use massive amounts of land to reduce greenhouse gas emissions. We know that this has significant side effects for biodiversity, for food security, for water security as well. And so that scenario is rather kind of an important piece of information to know what we should not be doing. We also know that there are many different ways, there are many choices we can make in how to reduce emissions deeply. And Leila has highlighted the importance of demand reductions. Demand reductions, as Shonali also highlighted in her presentation, provide across the board lots of synergies with the other objectives that we are trying to achieve. And therefore, if they can be implemented, can be something that is both politically and societally well supported.
Great, thanks very much, Joeri. So we've almost run out of time. I want to give one last chance back to the panelists for let's say a 10-word, 15-second sentence on what are your hopes from what you've learned? What can you take into AR7 in terms of innovation or speed or creativity to bring, as AR7 will start soon, and get people excited about this? And anyone want to go first? Joeri, you unmuted, so you're ready.
I'm
please.
Happy to kick it off. I think I have a hope for further integration of the different pieces of evidence that we have across the IPCC. Climate change is here. Our societies are experiencing it, are being hammered by the impacts. It is kind of almost irresponsible now to try and construct mitigation futures that do not take into account a world where the climate is significantly different. And so I think that integration, if we can achieve that better in the 7th assessment cycle, would be something that that would be very beneficial and very impactful.
Great, thank you. Then on to you, Shonali. Very quickly, 15 seconds.
Yeah, very quick response. Again, I mean, I think we are seeing increasingly that aspects of equity and justice are very, very critical for the acceptability of policies and actions. And that evidence is growing. And I think it would be really exciting to see a lot more of this sort of integrated within the AR7 cycle. I'll stop with that. Thank you.
Thanks. Okay, and then final words to you, Leila.
Thanks a lot. Actually, I'm a little bit was silenced because I'm really junior in comparing of Joeri and Shonali that have a long experience with IPCC. So yeah, from my point of view, also I agree totally with both of them. The integration is really crucial, particularly adaptation and mitigation strategies, because they have lots of co-benefits. And then in my point of view, it's very beneficial with we combine these two, and also looking through the biodiversity impact, because these are things that could have a higher impact. Regarding to the climate justice and social justice, also I'm very much sharing that this is really core and it's very important, and I hope that in the next cycle we can have more focus on that and bringing more practical kind of transitions way toward this perspective. Thanks a lot.
Good. Yeah, thank you. Important to make sure that everyone is involved. So we've run out of time. Thank you very much, everyone, for joining us today, and in particular for the many, many interesting questions that we are struggling to keep up with. We will try and follow up with you on some of them that have been unanswered. Video of this webinar will be on the IIASA website, but also on YouTube channel, and we will share the links that have been mentioned in the talk. Hope you've enjoyed it. We count on your opinion also to improve the future events that we do like this, so please really answer the quick survey that will pop up in your browser after you close the meeting. It's anonymous and will help improve them in future, and hope to see you again at the next IIASA webinar on Global Systems Analysis Centers in September 2023. You can follow us on social media for updates, and have a great day. Thank you to our speakers and to our audience. Good afternoon.